Hey everyone, welcome to today's lesson. Today's lesson has to do with combinations, which is basically almost the same as permutations, except order does not matter. Okay, so that's the key. In permutations, the order of things matter, and in combinations, the order does not matter. Okay, so let's let's show an example of when and why order doesn't matter when it comes to combinations. Okay, so let's say you have a selection of 10 juices. Okay, I just chose 10 letters here, and you can maybe there's a maybe there's a fruit name for each of these letters. Okay, apples, berries, cherries, dates, you're gonna have to think of that on your own. I don't know, but I just chose 10 letters. Okay, now um, obviously, if you're choosing three different kinds of juices, okay, to drink or to make a blend make a blend with, it doesn't matter what order you put it in the blender. Okay, it doesn't matter what order you drink it. You're just concerned with three different kinds of juices, okay, from a selection of 10. Okay, so this is a case where order doesn't matter. Okay, so Um, now, if order mattered, okay, so I want you to start it off as if order mattered. Okay, so in permutations, the way we just last did it, okay, we got 10 choices. So ignore this example right here. Okay, I'm just focused on this top example. Okay, you got 10 choices. Okay, and then you got 9 choices after selecting after you use up one choice, and you have 8 choices after using up 2 choices. Now this is how we did yesterday's when order matters. Okay, now because order doesn't matter, you're gonna have less arrangements now. Okay, you're gonna have less arrangements because, for example, it doesn't matter if you switch up the C and the A. Okay, all right, or let's say we chose C, B, A. Okay, all right. Now in yesterday's example, it would make a difference if you arranged it. These would be two unique arrangements. Okay, this would be two unique arrangements. But for today, when we're doing combinations, these would not be two unique arrangements. This would just be one arrangement. Okay, because order does not matter. Okay, so that's why we're going to have less than 10 times 9 times 8. Okay, and that, by the way, okay, 10 times 9 times 8 is 720. So that's going to equal to 720. We're going to have less than 720 arrangements for combinations. Okay. Um, and how much less? How do we know how much less? Well, you're going to divide it by, okay, 3 factorial. Okay, you're going to divide this by 3 factorial. Divide this by 3 factorial. If this said 4 different kinds of juice, then you would divide this by 4. Divide that by 4 factorial. Okay, if it's 5 different kinds of juice, it's 5 factorial, 5 factorial. Okay, so our final answer is going to be, okay, 720 divided by 3 factorial, which gives us 120. Okay, 120 combinations. Okay, there you go. Okay, so let's go ahead and let's look at number 2 right now. Okay, example 2. Now, here is a situation. Okay, you don't really have to pay attention to this middle stuff just so that this slide is not so busy. Okay, and you don't have to pay attention to that. We're only focused on this right here. Okay, we're really gonna see the difference between permutations and combinations. Okay, so I'm gonna make this in green here. And let's go. Okay, and I'm going to make this in blue like that. Okay, now for permutations, okay, permutations has to do, or well, let's start with combinations first. Okay, so combinations, okay, is when order does not matter. Okay, order does not matter with combinations. Okay, so if you look at these two examples, A and B, which one is the one where order doesn't matter? Okay, you can pause the video and think about it. Okay, order doesn't matter for choice A. Okay, because you're selecting just 3 people from a group of 5 people. Okay, so you don't care what order those 3 people are in. Okay, so in this case, you would do 5. You start it off like this. Okay, 5 times 4 times 3, and you divide it by 3 factorial. Okay, and then you would get 10. Okay, 10 combinations. Okay, all right. For the blue permutations, okay, permutations, order matters for this one. Okay, because in the pool of 5 people, I named it P1, P2, P3. Okay. If let's say I pick P1, P2, person 1, person 2, and let's say just person 4, just so it's not completely in order. Okay. All right. Now, in this example, so this is the position for chairperson. Okay. Chairperson, secretary, treasurer, chairperson, secretary, treasurer. Okay. Now, if I switch up, okay, if I switch up P1, whoops, if I switch up P1 and P2, okay, let's go like this. This is kind of getting in the way. If I switch up so currently the way it looks like right now, P1 is the chairperson and P4 is the treasurer, okay? But if I switch up P1 and P4, okay, right here, and P4 right here, then now P1 is the treasurer and P4 is the chairperson. So that's why order matters for B. Okay. All right. Whereas in A, you're just selecting 3 people, and the positions of these are not specified. Okay. In the permutations, excuse me, in the combination example. Okay. But when here's a key. Here's something to pay attention to. If there are names for their positions, okay, then chances are it's going to be a permutation. Okay, but if there are no names for the positions, okay, if there are no names for the positions, then it's probably going to be a combination. Okay, because then order doesn't matter. Okay, so in this case, this would be just 5 times 4 times 3, which equals to 60. Okay, and that lines up with what you see here. Okay, and 60 permutations. Okay, now next example. Okay, we're going through 4 examples here. Okay, now how many different ways are there to purchase 2 CDs from 7 CDs, 3 CDs from 5, or 3 cassettes from 5 cassettes, 3 videos, excuse me, 1 video from a pool of 3 videos? Okay, so 2 from a pool of 7, 3 from a pool of 5, 1 from a pool of 3. Okay, Well, let's just do the greens right now. Let's just treat the greens like a separate example. Okay? Like a separate problem. Okay? So I'm picking two CDs. That's 7 times 6. Okay? Over 2 factorial. Okay? All right. Now let's look at the yellow. Okay, instead of yellow, I'm going to use red right here. Okay, I'm going to use red. Okay, now let's look at the red. That's going to be, as a separate problem, that's 3 cassettes. Okay, that's 5 from a pool of 5, 4, 3, divided by 3 factorial right here. Okay. And here we have a pool of 3. We want to select 1 from a pool of 3, and that's 1 from a pool of 3. Okay. All right. So that's 3 over 1 factorial. All right. And then you multiply all these. Okay. And then you multiply all these. Okay. All right. Because this gives you 21 choices. This gives you 10 choices. And this gives you 3 choices. And you just multiply all these choices together and you get 630. Okay. 630. Okay. All right, and that's what we got here. Now, the reason you multiplied is kind of like this example that we did before. Okay. Over here, let's say you have remember we did this tree diagram? Okay, and you end up having 6 ways you can order. Okay, 6 ways you can order with these choices here. Okay, you got 2 choices here, 3 choices here, and the total is 6 choices, which is the same thing as multiplying 2, okay, times 3. Okay, so you multiply the choices, each choices, to get the total choices. Okay, so here we have each of these choices, and you multiply it to get 630 total choices. Okay, 630 total choices. Choices, ways, combinations, you can use either one of those. Okay, last example. All right, now let's look over here. Okay, in a recent survey of 25 voters, 17 favored a new city regulation and 8 opposed it. Okay, find the probability that in a random sample of 6 from the survey, exactly 2 favor the proposed regulation and 4 oppose it. Okay, so when it comes to probability, you always want the total sample space on the bottom. Okay, the total. All right, so the total is 25 people. Okay, the total is 20. You have 25 people, and you're interested in 6 from that total. Okay, 6 from that total. All right, so let me put this in black here. Boom. 6 from that total. So, and order doesn't matter because it's not saying that respondents have to be in an order, or it doesn't give you names for these positions of the respondents. It's just 6 from 25, and order doesn't matter. So we're gonna go 25 times 24 times 23 times 22 times 21 times 20, and we're going to divide that by 6 factorial. Okay? So that's your total sample space. Now, we're going to focus on the subtotal sample spaces. So we have a subtotal here of 17. Okay? And we also have a subtotal here of 8. I'm going to change this color now. Whoops. Okay. All right, so where's my blue? So my red is 17. All right. Whoops. That's my green. My red is 8. And my green is 17. Okay. All right. So we're looking for 2. So let's start with this green. We're looking at 2 out of the 17. We're trying to pick, we're trying to see, we're interested in two that favor out of the pool of 17 that favor. Okay, 17 times 16 over 2 factorial. Okay. Here we're interested in here, let me throw in some. This was green and this was red. Okay. Here we are interested in, for the red, we are interested in 4 that oppose it, okay, out of the pool of 8. Okay, so 4 that oppose it, that gives me 4 spaces, okay, out of the pool of 8. So I'm going to go 8, 7, 6, 5. Okay, you guys know it's times, I don't need to write it down, over 4 factorial. Okay, and remember, so let me just say this properly. We're interested in 4 that oppose it out of the pool of 8. So that gives me 4 spaces, 8, 7, 6, 5, divided by 4 factorial. For the green, we're interested in 2 that favor it out of the 17, 2 that favor it out of the pool of 17. So that gives me 2 spaces, and I go 17 times 16 over 2 factorial. And the grand total is, we're interested in 6 respondents. That gives me 6 spaces from the pool of 25. That's why 25 times 24 all the way to 20 divided by the 6 factorial. Okay, so the big thing I want to really hit home is that anytime you have probability, you have your total sample space on the bottom, okay, and then you have the subtotals that you're interested in, okay, the subtotals that you are interested in at the top. Okay, boom, boom, boom. Okay, just like if we're talking about quarters, what is the chance that you'll flip heads? Okay, the total sample space is 2 because it can be heads or tails. Okay, so that goes in the bottom. Okay, what you're interested in is just heads, which is just 1. Okay, that's 1 outcome. Okay, so it's 1 out of 2 in the case of flipping a quarter and getting heads. Okay, folks, that wraps up today's lesson. It is a little longer, but I think these concepts are pretty easy. Okay, the only thing you might have trouble on is example 4, but most of the problems are not having to do with example 4. Most of the problems for today are from the previous examples. Okay, I want you guys to do the green highlights. Okay, and that wraps up today's lesson. Thank you for listening.